As we said a couple of times, we're using water, which means 4 times more efficient to cool down than air. So this is one of the main drivers. The other part is that we're using only fresh air, what is required for the people and the minimum for the building. So with that, the fresh air requirements is much lesser, which means the AHU at the back will be smaller. And with that one, you can invest into high efficiency fans in that AHU, which will reduce further the energy consumption of it. The chilled water which we'll be using for the chilled beams is above room dew point, so it's a high temperature chiller. Typically on an AHU we're running with 7 to 12 degree water, 7 degree in, 12 degree out. Whereas on a chilled beam we're running with 14 to 16 degree water inside and 16 to 18 degrees outside. So with that one, the efficiency of the chiller also improves dramatically, which one saves again more energy. Chill beams bringing only the fresh air inside, which one is required for the people. We're not recirculating the air at the AHU. In a typical system, air gets back to the AHU, gets recirculated, gets filtered and gets blown again inside the space. With that one, there is a risk that the viruses growing at the AHU and blown in again. Whereas on a chill beam system, it stays within the room, so the person which is sick already, yes, will not get straight away well, but with the fresh air intake which one comes inside, the virus is around out in 1 hour if the person leaves the space and creates a healthy environment in that sense, so the neighboring room will be not contaminated with the virus of a person living in one room. Having even air distribution over the space gives you a very good thermal comfort, which also allows you to increase the room temperature from 24 to 25 degrees without even causing any discomfort for the people inside that space.
您不仅是妥思马来西亚地区的技术总监，那之前呢还担任过市场的销售总监。目前冷凉技术在欧洲市场已经是比较成熟了，但是在亚太市场的发展呢仍在推进当中。您认为是什么原因导致了这样的一个差异？冷凉技术在推广当中最大的挑战，您认为是什么？
Yes, Europe is matured in that sense. Also in Australia, the acceptance of chill beams is very, very high. In Southeast Asia, the biggest challenge is condensation. When you start talking to consultants, the first part is, oh, there we will have condensation, don't talk to me. To get over this hurdle takes a long time. Even we prove them with more and more tests. We can do it. There's condensation sensors. TROX has solutions also with the X-Air controls or TROX-OX. Systems in place to avoid condensation. Still, it is the biggest challenge to deal with, and it's a long process to change people's perceptions of medicine.
那刚刚有提到一点，就是说冷凉它还是可能存在截路的风险的。那至少对于大众而言，他们是这样认为的。那我们自己在研发上面是如何去突破这个技术难点的呢？
Okay, we're focusing in Asia Pacific, in both factories in China and in Malaysia, on this condensation issue. Of course, this is the biggest question mark from our designers and from our customers, as we are mostly in a tropically humid climate. There's several points which we did on testing. One part is we tested below room dew point and see really when is a condensation sensor reacting. Then we designed also products, especially with condensation trays underneath. So even there is a little bit of a condensation, it would go into a drip tray and it would not harm or damage any furniture in the space below it. So those are safety factors in it which we built into our products in the research and development in both factories to make the product safer for the end client to use, even we don't know what they are doing at the end.